Hello everyone, I've picked this question because we've got the scale pan with objects stacked on top of each other, which is always confusing because of the way it involves Newton's third law, and we've got an inclined plane. So I thought this is a nice question as it combines a number of factors that I know people find confusing. So it says a box of mass 5 kilograms sits on a smooth slope that is inclined at 30 degrees to the horizontal. It is attached to a light scale pan by a light inextensible string which passes over a smooth pulley, as shown in the diagram. The scale pan carries two masses, A and B. The mass of A is 2 kilograms and the mass of B is 5 kilograms. Work out the force exerted by A on B. So in this question, you'll notice that the slope is smooth and the pulley is smooth. So one of the most important things, well, yeah, very, very important thing in mechanics is always to get a good sketch first to visualize the situation that's taking place. Okay, so let's just get a quick sketch of the situation. So there's our two blocks, A and B. Here's our box on the slope. We have a normal reaction there, and we have 30 degrees. We have tension in the string and tension there. So that's our situation. We have 30 degrees here. There's our right angle. The weight of the block is 5g, and the weight of the two boxes, or whatever they are, in the scale pan is a combined weight of 7. So the mass of 7, so that's 7g. Okay, I think that's our initial sketch with all the information that we need there. So first of all, in this kind of question, we could definitely do with finding the acceleration first. So in order to find the acceleration, I feel like we should resolve up the slope first. So we're going to talk about for the box, because remember, it's a pulley system, so we need to deal with the objects separately because they're going in different directions. It's going to be moving up the slope because this weight is heavier than this weight, and the slope is smooth, so we can be confident that this one's moving down and that one's moving up. So resolving up the slope using Newton's second law, F equals ma, we have a tension pulling it up the slope, and we have the component of the weight acting parallel to the slope that's pulling it down the slope, and that's going to be 5g times by sine 30, because that's the opposite there. So we have tension minus 5g times by sine 30, and that is equal to our mass, which is 5, times by our acceleration, which we don't know. Okay, so there's our first equation. Now, let's consider the combined particles, and they are moving down. Okay, so this is now for the pan and the masses. And we're going to resolve down for these objects. Okay, using Newton's second law again, we've got 7g minus the tension is equal to the mass times the acceleration. And combined mass is 7, and the acceleration is a. So we've now got our second equation by considering the scale pan and the masses and resolving down. I'm going to do equation 1 add equation 2 in order to eliminate the tension and to find out what the acceleration is. When I add these two equations together, the tensions will cancel, and I'll be left with 7g minus 5g sine 30 is equal to 12a. So you add them together, they cancel, you've got your 7g, you've got your minus 5g sine 30, and then 5 add 7 is 12. In this equation, we know everything here, everything is known, so we can find our acceleration. And when we work that out, that turns out to be, the acceleration turns out, I think it's 147 over 40, which gives us an acceleration of 3.675, so 3.675 meters per second. Okay, which I think actually we could write that as A is equal to 3g over 8. That's another way of writing it, but either is acceptable in this case. Okay, so now we know our acceleration. That's good. Now let's turn our attention to the situation of the boxes that are on top of each other, or the whatever they are that's on top of each other, the masses. Now, the key for this one is you've just got to visualize. Imagine you are mass A, okay? What does mass A know? It doesn't know anything. It doesn't know that it's in a scale pan. All mass A knows is that it's falling down, okay? Gravity is pulling it down, and the only thing that it feels like that is slowing it down is some mass, some force coming from the floor, okay, which is being exerted on it by mass B below it, okay? So all A knows is there's a force that's pushing up from the floor, okay? And I'm going to call that FAB, the force that B is exerting on A. And what's pulling it down is its own weight, okay? So its own weight is just 2g. So that's all it knows, because A thinks to itself, if I wasn't being pushed up by the floor, I would just be falling freely under gravity, okay? The only thing that's slowing me down is a force of resistance that feels like it's coming from the floor to me. So that's life from the point of view of block A. So let's write down Newton's second law, F equals ma. So what have we got with that? We have got that the weight is pulling it down, and the force that's stopping it from just being in free fall is the force that's being exerted on it by block B, and that is what we're calling FAB. Okay, and that is equal to the mass, which is 2, times the acceleration, which we know is our 3g/8. Okay, that's fine. So we can rearrange this now in order to find out what that force is. So the force AB is equal to, just going to add that over here, take this over there, and when we work that whole thing out, that's going to be 6g/8 plus 6g/8. Just make sure everything's on the right hand side. Yes, 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 yes. 6g/8. Actually, it's going to be minus 6g/8 plus the 2g is equal to FAB. So I've just taken that over there and added this over here. And we work that out. That gives us FAB, turns out to be 12.25 newtons. Okay, now this is the force that B is exerting upon A. But the question isn't asking us for that. The question's asking us work out the force that A is exerting on B. So the question saying, what is the force that A is exerting on B? Well, using Newton's third law, that for every action there is an equal and opposite reaction, that means that the magnitude of the force that B is exerting on A is the same as the force that A is exerting on B. And very often with questions of this type, you need to sort of like reverse engineer how you think about it in your mind. So actually, in order to get the answer that we need, the force that A exerts on B, we just thought about life from the point of view of block A, and we considered what was the force that B was exerting on A, and that gave us our answer. So the force that we're after, the force that block A exerts on block B is 12.25 newtons, and that's using Newton's third law, that every action has an equal and opposite reaction. I hope that you found that useful, because that was dealing with inclined plane and we have objects stacked on top of each other, which I know people find tricky. And I will see you in the next video.